In this video, we're going to talk about amplitude and period. Let's start by tinkering with the basic y equals the sine of x equation. What happens when we multiply that by a number? So, for example, let's graph y equals 2 times the sine of x. Using a program called Desmos, which is a free online graphing calculator, I came up with this picture. The period is the same, and the wavelength is the same, but the amplitude is the distance from this midline, and the midline in this case is just right along the x-axis, and so the distance is 2. From the midline to the peak is 2, from the midline to the trough is 2. The amplitude is 2. Let's do another. Graph y equals 1/2 sine x. Pause the video and try to make a guess about what's going to happen. The wavelength and the period is the same, but the amplitude, I know the scale's a little hard to read, the amplitude is 1/2. So multiplying the sine of x by a number changes the amplitude, and it changes it to that number. So if we had y equals 5 times the sine of x, the amplitude would be 5. Let's multiply the input, the x, by a number. And maybe I should have put parentheses around this, but this is graphing y equals the sine of 5x. Before going on, stop and take a guess about what might happen. Here's our graph. This period was shortened by a factor of 5. So the period is how long it takes the wave to complete one full cycle. If it's starting from 0, how long it would take to go up, down, and back up to 0. For just y equals the sine of x, the period is 360 degrees. The period for y equals the sine of 5x is 72 degrees. How these numbers are related is if we take 360 degrees and divide it by 5, we end up with 72 degrees. The reason that this graph appears compressed is because when we multiply our input by 5, every increase of x is multiplied by 5. So we're moving through our cycle faster. Let's do another one. This time we're going to graph sine of 1/2 of x. Again, pause the video and take a guess of what's going to happen. If you guessed that this wave would be stretched out with a longer wavelength, you'd be right. So the period is stretched by a factor of 2. Instead of completing a cycle in 360 degrees, which is this midpoint right here, it takes a full 720 degrees to complete a cycle. Again, if our period is usually 360 degrees, we're going to just divide by that 1/2, and we end up with 360 times 2, because dividing by a fraction is the same as multiplying by the reciprocal, and we have 720 degrees for our period. The short of it is when we have a number multiplied in front, that changes the amplitude. Whatever that number is the amplitude. This number inside multiplied by our x changes the period, and the period is affected by being 360 degrees, so the normal period of a sine of x function, divided by the number b. Thank you.